So, hello all, and welcome to this next video in the sequence of image enhancement, where we are going to understand about point processing techniques. So, in my previous video, I've already told you the difference between the neighborhood processing techniques and point processing techniques for image enhancement under spatial domain. So, we will continue with the techniques of uh, point processing techniques for image enhancement, and this is our reference book. So what we have understood from the previous video is that point processing techniques are of uh, three types basically. Broadly they could be classified as three types. One is linear point processing techniques, then we have piecewise linear point processing techniques, and then we have non-linear techniques. So let us focus in today's video, let us focus on linear point processing techniques, wherein we will see what do we understand by identity transformation and what do we understand by digital negative transformation. So first of all, spatial domain techniques, and particularly in spatial domain techniques, point processing techniques, what do we understand by that? So if let me hold my pen once again. So if the pixel in the original image is called as r, okay, and on this pixel, if we apply some intensity transformation to obtain another pixel value in the new image or transformed image, we call it as S. This is the idea of point processing techniques. So the pixel value in the output image will be dependent on only the pixel value of that particular location in the input image. Now what will be this transformation will depend upon the technique that we are using. So here we have x-axis and y-axis. On the x-axis, we have all the intensity values in the original image and we call it as R. On the y-axis, we have all the values of the output image, that is the enhanced image. We call it all the intensity values of the enhanced image, we call it as S. So here if you see, there is one-to-one transformation between the input pixel value and the output pixel value. So if the original pixel value is 0, in the original image if it is 0, and in the output image, that is enhanced image, also it will be 0. In the original image if the pixel value is 1, in the output image also the pixel value will be equal to 1. In the original image if the pixel value is 5, in the output image also the pixel value would be 5. If in the original image, if it is a 3-bit image and L minus 1, for 3-bit image, 2 raised to 3 minus 1, which is equal to 7. So L minus 1 is equal to 7. So if in the original image the intensity value is 7, in the output image also the intensity value would be equal to 7. This is one-to-one mapping that we are doing, and this kind of transformation is called as identity transformation. Okay, so in this case, in case very simple transformation, in case of identity transformation, you can also say that input image is same as the output image, or output image that you obtain is same copy of the input image. So S is equal to R. But this is just for understanding. What do we understand? This is just to make us understand and realize what is transformation and how do you relate the input pixel value to the output pixel value. Okay, so this is simple transformation, identity transformation. Now if you look at this particular transformation function or transformation graph, very easy to understand what we are doing here. So this type of transformation that we have here, it is called as digital negative. See, just have a look at what is happening. So as I had already told you, R is the pixel values or intensity values in the input image. S are the intensity values in the enhanced image. So in the input image, if the intensity value is equal to 0, what is the corresponding value of the intensity in the output image? In the output image, it is L minus 1. So let me again take the example of 3-bit image, where my L minus 1 is equal to 2 raised to 3 minus 1, which is equal to 7. So if in the input image R is equal to 0, in the output image our S will be equal to 7. If in the input image R is equal to 7, in the output image S will be equal to 0, and so on. So how do we write this transformation function? This transformation function could be written as S would be equal to L minus R, L minus 1 minus R. Your L minus 1 is the maximum intensity value in the input image, and R is the current intensity value. And from the maximum value, you subtract the current intensity value to obtain the value in the output image. So this is called as digital negative. So let us take one example of digital negative here. We have to find negative of this particular image here. So what is the equation that we will be using? Here we have been given R's and we have to find S. So S, formula for S for digital negative is L minus 1 minus R. Now, what is L minus 1 in this image? If you see here, the pixel values could be represented by maximum of 3 bits, because the maximum pixel value that we have here is 7. So we require 3 bits for its representation. So your n is equal to 3. So 2 raised to n will be equal to 8. Hence, 2 raised to n minus 1, which is equal to L minus 1, which is equal to 7. So L minus 1 in our example is equal to 7. That is the maximum intensity level that could be there in this image. So S would be equal to 7 minus R. Now let us map the values. So if you make a table of R and S here, okay, if the value of intensity R is equal to 0, S would be equal to 7 minus 0 is equal to 7. If R is 1, S would be 6. If R is 2, S would be 5, and so on. So if R is equal to 7, S would be equal to 0. So by mapping these values of R to S, you will get the corresponding digital negative. So let us take example of this first pixel here. So if R is equal to 1, S would be equal to 6. So I will replace 6 by, in this, I will put value of 6 in this location in the new image. If R is equal to 3, for example, when R is equal to 3, S is equal to 7 minus 3, which is equal to 4. So 3 will be replaced by 4 in this example, and so on. So this is the simple example of digital negative and identity transformation. Thank you very much for listening, and in the next video we will continue with the point processing techniques.